Alright, so we are going to look at the third problem from yesterday's weekly contest. The problem states that we are given an array and an integer k, and we need to find two subsequents of size k such that if we do a OR values of one particular subsequence and a OR values of other particular subsequence and do a XOR in between, that will give the maximum value. It's an insane problem. Just bear with me. I have understood some other solution. I couldn't do it on my own, but now that I've understood it, I'll try to explain my level best. Uh, let's take this example. Size is 2. Let's do a brute force on it, right? I want a subsequence of all possible OR values of a particular subsequence. That's what I want, right? So uh, all right, so let's do it. So k is 2, right? So at this particular index, can I form a size of 2, including this and the ones before it? There's nothing before it, right? So I can't essentially create a subsequence of size 2. So I can't form any OR values using this. Okay, so let's do it here for this one. Uh, can I form a subsequence of size 2? I can. What will be the OR value? It will be just 4 or 2. That's it. That will be 6. Uh, can I form a size or a subsequence of size 2? I can. It will be 4 2. It will be 5 4. It will be 5 2. So we see a pattern that all the subsequences at this point will be all the subsequences from till the previous point, including the OR values that I can form using the current element. So 4 5 2 5. So 4 5 will give me 1 0 0 1 0 1. So it will be 1 0 1 5 itself, right? 2 5 will give me 6, right? 1 0 1, actually 7. 101 or with 010 will be 7. So but 4 2 will also be included, so 6 will also come here. Alright, now I'll do the same thing here. Like I said, I want the previous point till the previous point, whatever OR values I've gotten. Along with it, 4 6 will give me a OR, that will be 1 0 0 1 1 0 will be 6. So 6 is already there, so I don't want it again, right? It's not going to help me because, yeah, why do I need it again? Because 6 or 6 will be 6 only, right? So I don't need it. Actually, not 6 or 6, 4 or 6 will be 6 only, and that is already there. So I don't need it again. 2 or 6, this will be 1, it'll be 6 only, right? I don't need it again. 5 or 6, 1 0 1, 1 1 0 will be 7. I don't need it. Okay, it's already there. So let's do it with 7. So all the previous point or values will be coming here. Anything odd with 7 is going to be 7, right? So which is already there. So I don't have to do anything really. Now that I have all the subsequences from every element, if I do this, because I need two subsequences, right? And it should not be overlapping, right? And it should have a relative order as well, because subsequence is what that means. Order of the remaining elements should not change. I have to actually find the subsequence from the right side as well, right? So if I do this, actually let me copy it this much. From the right, let me do the same thing. Alright. So 7. 7 in itself will be just one value, so I can't really form a size of 2. I can't do anything. 6. 6 or 7 is the only possibility for a size 2. So 6 or 7 will be 7. So 7 will come here as well. Let me write it like this. Alright. 7 will come here, but this will also come, because this will also include 5, 6, right? 5, 7 will be 7. 6, 7 will be 7, which I've already taken. 5, 6 will be 7, so which is already there. Now 2. So 7 will already be there from the previous points. 2 will form 2, 5. 2 or 5 will be 0, 1, 0, 1, 0, 1, 7. 2 and 6 will be 6, so I will have 6 here. 2, 7 will be 7, so there's nothing more to it. This will come here. 4 or 2 will give me 4 or 2 will give me 6. 4, 5 will give me 5, so 5 will be added. And I think that's it, because 4, 6 will give me 6 and 4, 7 will give me 7. So this is what I get. Now I want, these are the OR values, these are the OR values from the left side, these are the OR values from the right side. I finally want a XOR in between such that it's maximum, right? Okay, so since we are doing brute force, we are just going to uh, so anything, this will be, if this is considered a subsequence, then I have to consider this subsequence, isn't it? If this is considered a subsequence, then I have to consider this as the right subsequence. If this is considered a subsequence, then I have to consider this as the right subsequence, but it's not valid because there is no other element. Alright, so I consider this, so I have to consider this. So 6 or 7 will give me 1, 1, 0, 1, 1, 1. This will be ORing, or if OR is done here between these two elements, it will be 1, isn't it? But if I do this, I'll do the same thing with all the other elements. If this is done, this will be 1, 0, 1, 1, 1, 1. This will give me 0, 1, 0. This is the answer, because I can't do anything else. That's the answer. So that's how we are going to solve this. We have to find the prefix, we have to find the suffix, and then we are going to do a basically brute force on that combination. But if we do this, we are going to get a TLE. I'm not going to do all the time complexity calculation here, but if we do that, we see with this constraint, we are going to get TLE. So now that we have the basic idea, let me jump into the, uh, you know, more towards the solution, because otherwise this video will be too long. So we have to find the subsequent. This is what we need to find. But if we try to find this straight away, we would get a TLE. But if we try to do it using DP, right? Basically, this is of size. This is of size 2, right? By size 2, I mean the subsequence is of size 2, what we have calculated it here. But what if I calculated for subsequence of size 1 and 0 first and use that to find the subsequence of size 2? Well, if I do that, then 4 for 4, uh, one single element, I mean, I want a subsequence of size 0, right? So it will be empty, nothing is there. I won't choose anything. Similarly, I won't choose anything. So it will be 0, 0, 0, 0, 0. In terms of bits, it will be 0 because I don't have a element selected, so nothing can be set to 1, right? A size of 1, so that will be 4 itself, 2 itself, or 4 as well, because I need all the subsequence of size 1, right, at this point. So I'll take the whatever previous index numbers were and take it forward. Similarly, or values of subsequence of size 1 will be 4 comma 2 comma 5, 4 comma 2 comma 5 comma 6, 4 comma 2 comma 5 comma 6 comma 7. So these will be the ones for size 1. Now what if I try to find it for 2? We already have it. Let's calculate and see if we are correct. So these are the OR values that I get for all the subsequence of size 1, right? Because one element in itself, if odd, will give the element itself, right? So now, if I want a OR of size 2 of all particular subsequence of size 2, so that will be nothing but anything that I get previously, like we were doing it here. We are taking things forward, right? So I have taken this forward here, 657 forward here, 657 forward here, right? But additionally, we need to find 2 XORed with 4 2, 4 and 2. That will be nothing but uh, so 4 ORed with 2 will give me 6, so it's already there. 2 ORed with 2 will give me 2. So I will definitely get some extra elements which I don't really need, but it's not going to affect my answer if you think about it, because at this point the maximum value, if I see, how should I explain this? It's pretty difficult to explain it in words, but 2 XORed with 2 will not affect my answer if it's added to the things that I don't even want it, but it's not going to affect my answer. I would suggest you try to do that yourself and see if it's not going to affect or if it's going to affect, but it's not going to affect. Now I'm going to take this forward. So this will have extra element of 2. So 2 will be there, and additionally 4 odd with 5, that will be 5. 2 odd with 5, that will be 7, it's already there. 5 odd with 5, that will be 5, it's already there. Okay, 2 comma 5 comma 6 comma 7. All right, but additionally I want 6 XOR 4, same thing, because it's already there. 6, 2 XOR 6, 6 is already there. 5 XOR 6, 7. Actually, yeah, 7. 7 is already there. 6 XOR 6 is 6. So, similarly, this will go here. Let me take this forward. Additionally, I want 4. Anything XORed with 7 will be 7, which is already there. So, this is what we get. Now, if I do the same thing here, but I'm not going to do it, and we try to find the same thing, we are eventually going to see that we get 2 as my answer. And that's the answer for this example. Finally, this is what we are going to use DP for, but we have to do some bit masking as well, because otherwise it will be, I don't know if there is other ways, but I found that bit masking was passing here. So instead of having a, so what do we need here, by the way? We need a 2D vector, as we can see, of size n and of size k, right? And inside that we have a vector of values, which is essentially a set, because we were getting similar values which we were not taking, right? So that is a set. Okay, but instead of taking it a set, I will try to find what all values can be here. What is the range of the values that is possible in a set? Now that we see 2 to the power 7, that will be 7 bits, right? Log of 2 to the power 7, log base 2 of 2 to the power 7 will be 7. So 7 bits, uh, that will be nothing but 2 to the power 7 will be 128. So minus 128 plus 128, that's what our range is going to be, right? Actually, I even need to have a minus 128? I don't think so. Just 0 to 128 is going to be the uh, our range of values. So I can, instead of using a set, I can have a vector of size 128 with a boolean value of I mean, even with a value of 0 or 1 if it's present or not. Alright, so let's start coding this up. We have gotten the concept. Let me copy this uh, in my notes so that I can see it as I code. Alright, so what basically I am doing is I am having a 2D array, but in that 2D array every element is also a vector, right, which is ranging from value 0 to 2 to the power 7, that is 0 to 128. So I'm having a 3D array of size n and size k plus 1 because I want from 0 till k, so 0 is also included, so k plus 1, and for each value there will be 128 possible values, so 129 will be the size. So essentially I will have a n which will be nums of size, and this will be basically uh, vector 3D vector of int. You can have a boolean value as well, since 0 and 1 is only going to be the only values, and this will be left. This will be vector of vector, oh, sorry, this will be of size n, and this will be of size k plus 1, and finally vector of int will be of size 129 with default value as 0. Let me copy this up for the right as well. This will be right. So I am going to traverse. So I'll start from I is equal to 0, I less than n, I plus plus, and then I'm going to traverse here this way. So I'm going to have int sub size, let me call this subsequent size, from size 0 till sub size of k. Alright, and finally I'm also going to traverse through all the values and find this, right? So essentially I'm traversing all the values which can range from 0 till 128. Alright, but I need to initialize few things, right? This is already initialized because it will have 0 values, so I don't need to worry about subsize 0, right? So I can start from subsize 1, isn't it? But if I start from subsize 1, uh, I would need, see, for 5, subsize sequence of, subsequence size of 1 will be from the last point forward, and this particular value will also be there, right, for size 1. So essentially I am having left of this particular index of size 1 will have nums of I by default, but since yeah, by default, so this will have everything. So 4 will be 4, 4 2 will be 4 2, but how will 4 2 4 will be 4 2 for index 1, right? That I'll have to take care here. If left I'm sorry, if left of I minus 1, so I'm suppose at this point I'm checking the previous values and transferring it here. So if left of I minus 1 for this particular size, for this particular val, if it's 1, then I will transfer it I minus 1, sorry, I sub size, transfer it to this index for this particular value. Alright, so I'm transferring it here. And finally, since I'm doing, by the way, I'm doing I minus 1 here, right? So I shouldn't start from 0, isn't it? I should start from 1. But what about then this 0 value? Oh, sorry, this 4 value, this should be there, right? But I'm not having, I'm not traversing from this index. I will have to initialize it here. or the first size nums of 0 is equal to 1. So we are good here. So at this point, if I'm here and I want for this size, right? So I'm essentially having 265 till this point. Since I'm taking this with this and I am taking this with this here. So I'm having 265 at this point, but I want 7 as well. How do I get 7? That I get from using the previous subsize value and ORing it with the current index, right? So previous subsize value for this particular index, since this index and this index I is same, for this particular index, the previous size minus 1 if it's 1, then left of I of subsize of vals should be set with vals or nums of I is equal to 1. This is what it should be set, and now we are good. We have this. Okay. So I'm going to do the same thing for the right. Exactly same, but just opposite. So we don't need to work our brain here. We'll have right. Instead of 0, I will have n minus 1. This will be same. This will be n minus 1. Wherever I is there, or wherever 0 is there, I'll have n minus 1. I will start from n minus 2 because I was starting from 1, and it will go till greater than equal to 0. I minus minus. Uh, this will remain same, but just it is for right. This will remain same. This will remain same. This will be for right. I plus 1. Subsize will be same. Vals will be same. This will be for right. This will be for right. This will be all same. This will be for right. Okay. And all good. Now that we have left and right, okay, I'm essentially traversing the indexes. So okay, let me traverse. I'll have result by the way here equal to 0. I will traverse. By the way, I can do the same thing here as well as I go at this point. At this point itself, I can have, but I'm having it here. There will be one extra O of n, but that's not going to change anything because it will be simpler and readable. Uh, so I'm essentially traversing. For each traversal, I'm basically checking. So if I'm at this index, I am, so I've not created a for, yeah, this is there, sorry. Uh, if I'm at 0 index, I am checking for 1 plus index for the right. If I'm at first index, I'm checking for the second index for the right. If I'm at the third index, so on and so forth. If I'm at the one before the last index and checking for the last index on the right half. If it's valid, otherwise not. So essentially, I'm traversing from 0th index to n minus 1 index. So this will be n minus 1. Yeah, n minus 1. And for each index, I'm traversing all of its values. So for this particular key subsize, I'm traversing all of its values. So values will be from 0 till 128 values plus plus. I'm checking if this value in the left half for this particular index, for this particular size, if it's 1, then I will continue and traverse all of the other values on the right half, which will be values 2. So I'll make this 1, 1, 1, values 2 equal to 0, values less than equal to 128, values plus plus, sorry, values 2 plus plus. If right of this particular index for this particular size, values 2, this is 1. If it's equal to 1, then it's valid, and at this point I will maximize the result like this, values 1 XOR values 2. Right, this is it. I can return result here. This is an insane problem. Let's submit and see if it works. Okay, there are some mistakes. Line 11. This should be a semicolon. Let's see if this works now. Oh my bad, I copied it, that's why. Okay, there is some mistake. Uh, Actually, this should be I plus 1, my bad. See, here we are checking. Uh, we are checking one ahead in terms of index between left and right? So this will be I plus 1 and this. Yeah, let's see now. Okay. Alright, so what I missed here is, see, at this point and at this point, we are checking for the previous size rate. We are having the additional elements that we can have. So from here, we got 4 2, but we got this additional element by ORing 0. I mean, no elements with 5, so that we got 5. Now that we see here 2 6 we got from the previous element, but 5 7 we got from ORing 4 2 5 with 5. That's how we got 5 7. But till this point, at this point we are doing it one by one, right? We might not have 4 2 yet initialized for this index, so we should do it for the from the previous index. We should check. So it's little bit complicated, but if you think about it, you will get it. It's left of I minus 1 if it's equal to 1. So if 4 is there, then I'll do a 4 or 5, because 4 will be here. Right now it is not By the time this loop ends, it will be here. But that does not mean that I should skip it when I have to do it for the additional elements, right? So I will check it from here so that I will always have all the additional elements that I need. Similarly, for the right one, I do it for I plus 1. I'll have a check for I plus 1 instead of I, and that's it. Let's see if this works. Let's submit it. Time complexity is not that difficult. See, we are having a n index, and we are running a loop over k size. 128 is constant, so O of n into k. This will also be O of n into k. This will be even lesser, so we don't have to worry about it. And so O of n into k, which is n is 400 and k is 200. So 8,000, 80,000 is it? So whatever it is, that's the time complexity, n into k, and that's the question. Thanks, guys.